This is Algebra 2, Unit 5, Lesson 3 on summation notation. Much of our work in this unit will concern adding the terms of a sequence. In order to specify this addition or summarize it, we will introduce a new notation known as summation or sigma notation that will represent these sums. This notation will also be used later in the course when we want to write formulas and statistics. Okay, now it's called summation or sigma notation because this is the Greek letter sigma. And it indicates that you're adding things together. Now, what do you add together? Well, you notice this is sigma, I equals A of n, f of I equals. All right, now, I is called the index variable. So that is what you are going to be plugging in. All right, so that's the index variable is I. A is going to be the starting value. So A is the starting value, and then it ends at the value of n, or whatever you do. So you would plug in whatever this number is, first term, and then you'd want to go to each successive term. It moves by unit increments, one at a time. All right, now this kind of notation looks a little weird when you see it, but if you take a look on how it's actually used, it makes a lot more sense. Okay, so let's evaluate each of the following sums. We have the sigma notation of I equals 3 to 5 of 2i. So what this means is if I is 3 is going to be your first term, you would take 2 times I would be 3. All right, and then you're going to add, what would be the next term after 3? Would be 4. So that would be 2 times 4. And then your last term would be 2 times 5. So you are doing the summation of 2i going from 3 to 5. Okay, so 2 times 3 is 6, 2 times 4 is 8, 2 times 5 is 10, 6 plus 8 plus 10 is 24. So this is just basically saying sum up 2i starting at 3 and ending at 5. That's pretty much what it all says. Okay, so let's look at letter B. What is the first term of my sequence going to be? Or what's my starting value of my sequence? Well, it's going to be k is negative 1. So this is going to be negative 1 squared is going to be my first term. How far do I have to go? Well, I start at negative 1. When do I stop? I stop when I get 3. So this is going to be negative 1. The next term up would be 0 squared, and then 1 squared, 2 squared, and 3 squared. Oops, not 3 times 2, 3 squared. Sorry. All right, so I take each successive terms of the sequence starting at negative 1 and ending at 3 and square them and then add them together. So negative 1 squared is 1, 0 squared is 0, 1 squared is 1, 2 squared is 4, and 3 squared is 9. If I add them together, 1 and 1 is 2, and 4 is 6, and 9 is 15. So there is my answer. Okay, now let's try this one. The summation from j equals negative 2 to 2 of 2 to the j. All right, so what am I going to put in first? Well, I'm going to do 2 to the negative 2. That would be my first term. Plus 2 to the negative 1. Plus 2 to the 0. And when do I stop? When I get to 2 to the 2. Okay, so 2 to the negative 2 is 1 over 2 squared, which is 1/4. This is 1/2. 2 to the 0 is 1. 2 to the 1 is 2. 2 squared is 4. Okay, so if I add these together, I get 4 and 2 is 6 and 1 is 7 and a half and a quarter is 7 3/4, 7.75 or 7 3/4. Now, it's a little complicated figuring out what to do if you write them out separately, but it's really easy to see where the numbers come from when you do that. Okay, yes, you can do that on your calculator. So if I wanted to do these on my calculator, there is a summation button, but it's only used when you're plugging in values. If you're plugging in variables, it doesn't work. But let me show you. Let's look at the first one, for example. All right, so if I go to my calculator, if I press the green alpha key and the window key, look at number 2. There's that sigma symbol is right there. So if you pick number 2, okay, now it starts down here at the index. I usually just use the x there, whatever it happens to be. So I'm going to use x. And our first one was x equals 3. And then when you use the up arrow to go up here, you were going from 3 to 5. And then the index out here, or excuse me, the function out here was 2x. So instead of using I just use x. You can use actually any letter you want as long as this matches what goes here. So we said the answer was 24. Let's see if it is. Yep, it was. Okay, so let's do the second one. The second one was from k equals -1 to 3. We're just going to use x instead of k. All right, so alpha window key, going to use the summation, number 2. And it was x equals -1 or k equals -1. And then to 3 of k squared, or so this is going to be x squared. All right, enter. And that was 15. It worked. 15. 15. Okay, let's do one more. All right, so we're going to do the summation, which is number 2, from -2 to 2. So x equals -2 to 2, and my function was 2 to the j. All right, so raised to the, I'll just use x, enter, with 7.75, which is 7 3/4. So that works out quite nicely. So you can do this on your calculator, you just have to know what this means when you were doing it as well. All right, let's try the next one, see what we end up with. If you see this one, all right, let's try the next one and see what we get. The summation from 1 to 5 of -1 to the I. All right, so that means we take -1, raise it to the first power would be 1. And then I want to keep doing that until I get to the 5th power. So -1 to the 3rd, -1 to the 4th, -1 to the 5th. Okay, so -1 to the 1 is going to be -1. -1 squared is 1. -1 to the 3rd would be negative, would be -1. -1 to the 4th would be +1. And -1 to the 5th would be -1. So this should work out to be -1. Okay, so if you're doing this in the calculator, again, you want to do alpha window key summation number 2. All right, so it would be x equals, the first term was 1, to 5 of parenthesis -1 raised to the 5th. Now notice I'm putting the parentheses inside here because I want to make sure the negative gets, or excuse me, the x, not the 5th. I want to make sure that the -1 gets the power applied to it when you do that. All right, so we end up, let's see if we get -1. It worked. Okay, so the summation of 2k plus 1 starting from k equals 0 to 2. So this is going to be 2 times 0 plus 1, 2 times 1 plus 1, and then 2 times 2 plus 1. So 2 times 0 is 0, plus 1 is 1. 2 times 1 is 2, plus 1 is 3. 2 times 2 is 4, plus 1 is 5. 1 plus 3 plus 5 is 9. There we go. All right, now if I want to do it on my calculator, alpha window key, summation, x equals 0 to 2 of 2x plus 1. Notice that you make sure that your index and your value that you put in for f is the same. And it equals 9. So we got the same answer. All right, so let's do one last one here. I equals 1 to 3 of I plus 1. All right, so let's start with that. All right, so my first term is going to be 1, so that's going to be 1 times 1 plus 1 plus 2 times 2 plus 1 plus 3 times 3 plus 1. All right, now let's do this one in the calculator. All right, so summation number 2, we have x equals 1, and then going to 3 of x times x plus 1. Let's see what we get. And I end up at 20. So that works out to be 20. Okay. So you can see on each one of these, all you have to do is you have to know what your starting value is, plug it in, and go to the successive values until you get to the top number. All right, let's try the next one. Which of the following represents the value of I equals 1 to 4 of 1 over I? Okay, so this one I'd probably put in my calculator. Grab my calculator. Alpha window key. I'm going to use summation. All right, so I have x equals 1. And I'm going up to 4 of 1 over, in this case, 1 over x. So 1 divided by x. Okay, enter. And I get this. So to make it a fraction, just hit the math key. Enter, enter. Now, if you had put it in using the alpha key, y equals, it would have come out 25 over 12 to start with. But you can see that is the answer is 25 over 12. Okay, so that should be number 3. Okay. All right, so let's try this next one. Consider the sequence defined recursively as a of n equals a of n minus 1 plus 2a of n minus 2, and a of 1 equals 0, and a of 2 equals 1. Find the value of a of I from 4 to 7. Okay, so basically, what are they telling us to figure out? We need to know, well, our first term is going to be a to 4, and then we're going to add a of 5 plus a of 6 plus a of 7 to get the answer. So in order to do that, we need to know what a of 4 is in order to do that. So let's see if we can figure it out. All right, so in order to know a of 4, we have to know, by this, we have to know the previous term, because remember, a of n minus 1 means the previous term. And we also have to know to add 2 times previous, 2 previous when we do that. Okay? All right, so we know a of 1 is 0. A of 2 is equal to 1. All right, so what is a of 3? Well, a of 3, according to this, would be the previous term, okay, which would be a of 2, plus 2 times the 2 previous to that. Well, 2 previous to this one would be a of 1. All right, so let's see. A of 2 is 1, and a of 1 is 0, so that would be 1 plus 2 times 0 is just 1. All right, so a of 3 is going to be 1. All right, so to figure out a of 4, we need the previous 1 to 4 would be a of 3, plus 2 times the 2 previous to it, which would be a of 2. All right, so this would be a of 3 is 1, plus 2 times a of 2, which is 1. 1 plus 2 is 3. All right, so we know this one's going to be 3. Okay, let's do a of 5. According to this, we need to know the previous to 5 would be a of 4, plus 2 of the 2 previous to it. The 2 previous to it would be a of 3. So a of 4 we found was 3, plus 2 times 1. 3 plus 2 times 1 is equal to 5. Okay. All right. So this one's going to be 5. Let's do a of 6. All right, that would be 1 previous would be a of 5. 2 previous would be a of 4. So let's see. A of 5 was 5 plus 2 times 3. So that is going to be 11. And we need one more. A of 7 would be a of 6 plus 2 a of 3s, because that would be, or a of 5, I'm sorry. 2 previous to 7 is a of 5. And then that is equal to a of 6 is 11 plus 2 times 5 is equal to 21. So if I add these together, this is going to equal 3 plus 5 plus 11 plus 21 is 40. So that equals 40. Okay, so that's some examples of sigma notation. We should be able to place some sigma notation as well, so we are going to work on the rest of this in class the next day.